Hey there, second grade. How's everybody doing today? Welcome back to another remote learning math lesson with Mr. Endy. Today, we're going to take a look at some subtraction strategies as we count up and count back to see which way is most efficient. Ooh, a word we're going to talk about. So today, you are going to need something from your grade 2 Math resource pack that came with your sheet protector. One of those pages that are inside that resource pack is a sheet that has two large number lines. You are going to want to find that sheet, take that sheet and place it inside your sheet protector so that you can use a dry erase marker to write on it and practice over and over again. So go ahead and search for that sheet within your Math resource pack. It's the sheet that has two big number lines on it. Go ahead and look for that because I am ready to shrink myself into the corner as we get started learning grade 2 lesson 3.5. Subtraction strategies, counting up, counting back. And you will need your number lines, Math, and your sheet protector and your marker for today's lesson. So hit that pause button if you are still searching for it. So our first big word today is the word efficient. Say that word, efficient. Now, efficient means working in a way that gets quick results. Yeah, if I had to go get my mail, I would probably walk straight to my mailbox. That would be an efficient way to get my mail. If I decided to walk all the way around my house 3 times, do some cartwheels in the yard, and then go get my mail, that's not efficient. That's not a very quick way to do it. Well, in math, we have some strategies that are efficient. They're quicker, and we get the right results. We get the right answers. So today, we are going to be looking at counting up and counting back as we try to find which strategy is most efficient. So let's take a look at our first strategy we are going to be practicing today. The strategy is called counting back. And that's because we're going to count backwards. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 16, 15, 14, 13, 12, 11, 10. So we're going to count back to solve a subtraction problem. And here's the two ways that we do it. We put the greater number in your head. And then you count backwards. So here's my problem. 7 minus 2 equals 5. I put the bigger number in my head, 7, and I count back 2. 6, 5. 6, 5. So on my number line, I showed what I'm thinking in my head. I started at 7, and I counted back 2. 1, 2. Because that's what this number model means. Start at 7, count back 2. And we landed on 5. So counting back can be an efficient strategy sometimes. But we also have another strategy. That strategy is the total opposite. It's called counting up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10, 11, 12. 9, 10, 11, 12, 13, 14, 15. I count up. And this way works a little bit different. This time we put the lesser number in your head, and then you count up until you reach the greater number. 7 minus 2 equals 5. This time I start at 2. That's the smaller number. And I have to hop up until I get to the 7, because that's my other number. So 2, 3, 4, 5, 6, 7. I hopped up 5 times. And I showed what I was thinking on my number line. Start at 2. How many hops does it take to get to the 7? 1, 2, 3, 4, 5. So my answer is 5. Now, of those 2 strategies, one of those strategies is efficient for the problem 7 minus 2. For this problem, when I counted up, I had to make 5 hops. 2, 3, 4, 5, 6, 7. But when I counted back, I only had to make 2 hops. 7, 6, 5. This way, counting back would be quicker for a problem like 7 minus 2. It wouldn't be quicker if I was counting up. It takes longer. It's not efficient. So today, we're going to take a look at some number models. And we're going to try and solve them on our number line to find out which strategy is more efficient. Let's start with our first problem. Make sure your sheet protector is ready to go. We have the problem 12 minus 9 equals. Well, go ahead and write that number model on your number model line on your sheet protector. It's at the very top. Number model, 12 minus 9. Now we're going to use the 2 strategies to solve the problem. The first time, we're going to use counting back. We're going to count backwards. So let's go ahead and use our top number line to count back. Well, put the greater number in our head. Well, the greater number is the number 12. So on my number line, I'm going to go ahead and put a dot at the 12. And I want to count backwards. But I have to count backwards 9 times. 12 minus 9. So let's hop back 9 times. 11, 10, 9, 8, 7, 6, 5, 4, 3. I hop back 1, 2, 3, 4, 5, 6, 7, 8, 9 times, and I landed on 3 because 12 minus 9 equals 3. So I'm going to go ahead and fill in that answer on my sheet protector. 12 minus 9 equals 3. So when I counted back, I had a lot of work to do. 12 in the rock. 11, 10, 9, 8, 7, 6, 5, 4, 3. I counted back 9 times. That was a lot of work. Let's take a look at our next strategy, counting up. So let's go and write 12 minus 9 again on our next number line spot. So now I'm going to write 12 minus 9 again. But this time, we're going to use the counting up strategy. Now remember, the counting up strategy says start at the smaller number, 9, and stop when you get to the bigger number, 12. So I put 2 dots on my number line. I'm going to start at 9, and once I get to 12, I'm going to stop. So I have 9 in my rock, 10, 11, 12. 9 on my number line, 10, 11, 12. How many hops did I make? I made 3 hops. So my answer is 3. Well, that's true, right? We already found that 12 minus 9 equaled 3 on the first time we did it. Which of these ways is more efficient? Which of these ways did I have to make less counts? Counting back or counting up? Well, hopefully you said counting up is the quicker way for this problem. 9, 10, 11, 12. The difference is 3. 9 and 12 are 3 away. So for this problem, counting up is efficient. It's quicker. Let's erase our sheet protector and let's try another one. This time our problem is 11 minus 3. Go ahead and write 11 minus 3 on your number model line. We're going to figure out the answer to 11 minus 3. And our first strategy is the counting back strategy, where we start at the bigger number and then we count back the next number. So let's put a dot at 11. Start at 11, count back 3. 1 hop, 2 hops, 3 hops. 11, 10, 9, 8. Where did I land? I landed on the 8. So that means 11 minus 3 equals 8. So counting back was pretty quick this time. Let's see what happens when we count up. Let's go ahead and write that number model again on our next number model line. 11 minus 3 equals, and let's try the counting up strategy. So for the counting up strategy, we put the smaller number in our minds, and that smaller number is 3. And we want to count up until we get to the bigger number, which is 11. So we have to make hops to connect those two dots. Let's see. 3, and then we go to 4, 5, 6, 7, 8. Oh, I'm getting tired. 9, 10, 11. How many hops did I make? 3 in the rock. 4, 5, 6, 7, 8, 9, 10, 11. I made 8 hops. My answer is 8. Well, we know that, right? We figured out it was 8 when we counted back. When we counted up, we had to make all of those hops. Which strategy this time is the efficient strategy? This time, it's counting back. Wow. That means it depends what type of a number model it is as to which strategy is more efficient. Let's try another one. This time, we have 9 minus 7. Let's clear our sheet protector and write down our new number model. 9 minus 7. Now, notice that the number 9 and the number 7 are pretty close together on our number line. Here's the 7 and here's the 9. I wonder which strategy is going to be quicker. Let's see. Count back. Put the greater number in our head. 9. Start at 9. Count back 7. Well, let's go ahead. Let's make 7 hops backwards. 1, 2, 3, 4, 5, 6, 7. Oh my goodness. 9 in the rock. Count back 7 times. 8, 7, 6, 5, 4, 3, 2. I landed on the number 2. 9 minus 7 equals 2. I had to do a lot of work when I counted back. Let's try to count up. Go ahead and write the number model on your next number model line, because this time we're going to count up. Count up is when we start at the smaller number. We're starting with the 7, and we want to count up until we get to the number 9. 7 in the rock, 8, 9. 7 on my number line, 8, 9. How many hops did I make? I made 2 hops because that's my answer. 9 minus 7 equals 2. Which of these ways was more efficient? Was it counting back or was it counting up? This time it was counting up. And remember what type of problem this was. My 2 numbers were close together. So when numbers are close together, counting up is the better strategy. It's more efficient. How about 12 minus 6? I want you to hit the pause button. I want you to try to count back and to count up and tell me which way is more efficient when we solve 12 minus 6. Go ahead, hit that pause button and try the 2 strategies and see what you get. When you're done, press play. We'll check our answers together. All right, 2nd grade, hopefully you finished this one. 12 minus 6. So when I counted back, I started at 12, and then I counted back 6. 1, 2, 3, 4, 5, 6, and I landed on the number 6. 12 minus 6 is 6. And then I had to count up. And when I count up, I start with my smaller number, the 6, and I want to count all the way up until I get to the 12. And I counted 1, 2, 3, 4, 5, 6. Which of these ways is more efficient? This might be a trick question. Which way do you think's more efficient? 6, 7, 8, 9, 10, 11, 12. 12, 10, 11, 10, 9, 8, 7, 6. Did you say that they're both the same? They are exactly the same. It's not easier either way. Wow. Do you know why? This is a doubles fact. 6 plus 6 equals 12. So whether I count up or whether I count back, I'm still going to have to make 6 hops. So neither way is more efficient when it's a doubles fact. Today, you are going to have a chance to try and solve some subtraction problems. And you're going to want to try and find which of the 2 ways, counting up or counting back, is the quicker strategy for you to use, because that's going to make you a better mathematician. All right, go ahead, log into your Seesaw activity and get started. I can't wait to see how smart you are.